So in this video, we are going to study the failure and troubleshooting is carried out in hydraulic system. These are the most common failure and troubleshooting methods in hydraulic system. The first step is failure cause is pump inlet strainer. This can happen on a new system after only a few hours operation, as well as on a system which has been in service for a long time. It produces the symptoms described above: increased pump noise, loss of high pressure and or speed. If the strainer is not located next to the pump inlet, it will usually be found immersed below the oil level in the reservoir. Some operators are not aware of this strainer, or if they are, they do not give in attention until the system fails, at which time the pump may be ruined. If not regularly cleaned or replaced, or sooner or later the strainer will become sufficiently restricted to cause a breakdown of the entire system. The second cause may be pump and relief valve. If cleaning the pump inlet strainer does not correct the trouble, isolate the pump and pressure relief valve from the rest of the system by disconnecting the plumbing at point B and capping the both ends of the disconnected lines. The third cause is pump and relief valve. Further testing must be done to determine whether the pump or relief valve is at fault. If possible, disconnect the tank return line from the pump valve at point C. Attach a short length of hose to the relief valve outlet. Hold the open end of the hose over the tank filler opening where the rate of oil flow can be observed. Start the pump and run the relief valve adjustment up and down while observing the relief valve discharging flow. If the pump is bad, the full stream of oil may possibly be observed when the relief valve is backed off, and this stream will greatly diminish or stop the relief setting is released. Then fourth cause may be a pump. If a full stream of oil does not obtain in step 3, if the stream diminishes markedly as the relief setting is raised, the pump may be worn out. Assuming that the inlet strainer has been cleaned and the inlet plumbing has been examined for air leaks or collapsed hose, the oil is slipping externally from the outlet back to inlet. The pump may be worn out or the oil may be too thin. Excessively high temperature in the oil causes the oil to thin out and slip excessively in the pump. High slippage in the pump causes it to run much harder than the oil in the tank. In normal operation with a good pump, the pump case may be run 20 to 30 degree Fahrenheit more than the tank oil temperature. If greater than this, excessive pump slippage may be cause. Then fifth cause is pressure relief valve. So already it is indicated in step 3. The quickest remedy is to replace with one known to be good. The faulty valve may later be disassembled and cleaned. Pilot operated pressure relief valves have some internal orifices which may become blocked with dirt. Blow out all passages with an air hose and run a small wire through orifices. Check also free movement of the spool. Pipe thread connection in the body may distort the body and cause the spool to bind. If possible, check for spool bind before removing threaded line connections, or while testing on the bench, screw pipe fittings tightly into the port threads. The last cause may be direction control valve. If the cylinder has been tested for piston leakage and found to have a reasonably tight piston, the four-way direction valve may be checked for excessive spool leakage. It is rare that a valve become worn so badly that the pump cannot be built up full pressure, but it can happen. Symptoms of excessive leakage are a loss of cylinder speed together with a difficulty in building up to full pressure even with the pressure relief adjusted to high setting. This condition would be more likely to happen when using a pump with a small displacement operating at very high pressure and might have developed gradually over a long period of time. So these are the possible causes and remedies of hydraulic system breakdown. Thank you, students.